Hi everyone, welcome to another video in the CBM Flux Studio series. If you're following along with my blog, you might know that I'm actually rewriting the application from scratch. The reason for that is that I'm changing the underlying data structures, and that's something that will greatly simplify my life for implementing some of the most complex features that I plan to add to the tool. 2.0 might actually be the version that goes out to the general public. It all depends on what I can fit in. At the moment I'm fitting features from version 0.9. Again, that was the first generation of the tool. And in this video I'll take some time to actually show which bits have been ported over. Let's start with a Vorpal disk. In this case it's a DTC generated G64 file, and for such files there are a little bit of extra options available. Let's do the alignment to the right splice to start with. So that has been put back in, and very quickly, a right splice is a concept that is quite important when trying to write a disk image back to disk. Specifically, it's a hint to DTC in this scenario, in this G64, to say start writing a track back to disk from this point onward. And the reason is that because the track is circular, there is a chance that the last few bits that we're writing for a track actually overwrite the initial bits in a track. It's the sequence is never gonna cycle back perfectly, so we need to make sure that there isn't a data in the zone where we are starting and ending a write, and that's what the lead-in and trailers are for. Now, I made an observation while I was playing around with the realignment to the right splices. As you can see, the right splice for all the tracks is quite different when compared to the even ones, and you can tell because for the odd ones there is this extra sequence that seems a little bit strange, and you can see the soft sync is actually over here, where for even tracks it comes much earlier. As you can see, for odd tracks is always around this area. I left in this density zone. So I was thinking about this and I realized, okay, I know what's going on. Pretty much DTC is taking a safe bet, yeah. But what it's doing, rather than recognizing that there is a trailer that looks different than the lead-in, and there is also a stop sequence to that trailer, what it does is it puts together trailer and lead-in and just splits them in the middle. As you can see on all the tracks, the trailer is very long, so it's not surprising that when you add a long trailer and a pretty much constant size lead-in, when you split them enough, you're actually ending up with the right splice in the trailer itself. For even tracks, it's the other way around. This is the trailer, it's very small, and because the lead-in is longer, when you put them together and divide enough, what you end up is a right splice in the lead-in sequence. Now, I'd like to make a point clear about this stuff as well. The fact that the write splice has been put here means that yes, we will write the track safely back to disk from here, but it doesn't actually mean that the original track was written starting from here. What is a better definition for a write splice is actually the point at which we finish writing a track. Realistically, back in the day, what would have happened, and this is particularly true with the CBM format, with the standard DOS, but it's probably true for other formats as well. The track was first filled in with filler bytes, which are these ones. Yeah, and then at some point, the very first block sync, in this case a soft block sync, was written, and then the whole track was written, and then the trailer was written, the stop sequence was written, and that has essentially overwritten the filler byte and only left this many in this track specifically. Again, this is an important point to understand what I'm going to discuss next. It's along the same lines, but I think a better way to look at the write splice is actually where are we going to finish writing a track. By all means, it's the same in this case, because there are no extra bits, no extra filler bits here that we need to consider. But for the purpose of mastering these disks, it's slightly different. It would realistically be better to refer to a write splice as the point at which we stopped writing data to the track. Let's have a look at a standard DOS disk, and for this one I reintroduced the option to align tracks to block 0, to the block 0 block sync. As you can see, if I go on the block sync for each track, it's always sector 0 of the given track I'm on, and this is all nice and cute, but for the very same reason as I discussed for Vorpal, this is not where the track was initially was written from. The idea is that the track, there was a filler byte that was written to the track to essentially just create a level playing field, and then what happened is that at some point the write started from block 0 to the end of the track, and a little bit of the end might have overwritten the filler bytes. Now it would be tempting to think that this is the end of the trailer, and this gap here is where the erase call has erased part of the filler byte, and that essentially the track was written and the write process for the track ended here. So it'd be tempting to assume that, right? You could say, yeah, this is where it ended. Over here there was the filler byte, and the gap is more than a couple of bits here, because whatever created this G64, whatever tool created it, actually added the necessary padding in these points to make sure that track data was a whole number of bytes worth of data. The reality is that I wasn't satisfied with this speculation. So what I did is I created I formatted the disk with the DOS command N0, and I started looking. How does this stuff look like? And as you can see, for track 1, this nib file shows that sector 0 is pretty much in the middle of the sample I took. And incidentally, for track 2, the block sync for sector 0 is in the neighborhood, so we can essentially hit two birds with one stone in this case. And have a look at this one. This is quite telling. This is telling us that the track was written and the write process ended up here. And you can see the erase coil has actually overwritten, actually removed one of the bits that was there for the filler byte. Again, the filler sequence was originally much longer than what we see here. It was pretty much the way this is done is, I think it's pretty much a whole track worth of bytes. Don't quote me on that one, but it's a lot of these filler bytes. And then it starts writing the block sync for sector 0, writes the whole track, and has got this final intersector gap here. And this is essentially where we stop writing. So a better way to actually align this track, and also to put the padding required to convert it to G64 and make each track data a whole number of bytes worth of data, is to use this and put the right splice here. Again, very important, especially for the process that we know about. The right splice is better looked at as the point at which originally the track stopped. Well, the write process ended. So that's the point where the write process ended. Now have a look at where these effects are showing up. It's always a lot of filler bytes before the block sync, and there is a very few intersector filler bytes at the end of the last sector for each track. So this is pretty much, the way that the track was written. The write process ended here for this track, the write process ended here for this track. And that's why, again, I think any padding and the start of the track when we realign should be put here, rather than being put as we saw earlier for this one, rather than putting the block sync at the beginning of the track. Makes no difference during an emulation, but it's a much better representation of how to safely write a G64 back to disk. I'd like to close with saying that the circular plot has been reintroduced from the previous version of the tool, so it's there. So is well, the GCR decoder is really pretty much for myself. Manual track alignment has been reintroduced as well, and yeah, that's pretty much where I am at the moment with the rewrite. But yeah, keep watching this space, because I'm gradually adding more and more features and actually enhancing on the work that I did for version 1. I hope you enjoyed the video, and thank you for watching. See you in the next one.